Jaguar Cars Incorporated presents Suspension and Drivetrain, Part 2. As seen in Part 1 of this series, the Jaguar suspension system combines sound engineering principles with high-quality construction techniques to produce superior road holding, handling, and ride. Part 2 will concentrate on rear suspension service information, drivetrain system description, and drivetrain service information. The rear suspension system integrates drivetrain, braking, and suspension functions into one unit housed in the subframe assembly. Servicing this assembly requires the consideration of all these functions. The four rear coil shock units combine springing and dampening into compact units. Springs must be replaced in sets of 4 only. Use tool JD11B and a press to compress the springs for removal and installation. Each set of coil shock units is mounted on a common lower shaft. Note the position of the spacer between the forward coil shock and the wishbone, and the position of the 2 washers, one at the forward end and one between the rear coil shock and the bracket. Rubberized bushings are used at the shock absorber pivots and at the radius arm pivots. This requires that they be tightened in the mid-laden condition. After installing the coil shock assemblies, tighten the upper mounts only. Carefully jack under the outer end of the wishbone to compress the springs and install the BLT 5023 mid-laden hook. Torque the lower shock absorber pivots after installing the hook. It is necessary to tighten only the radius arm rear hardware in the mid-laden condition. Be sure to bend over the lock tab after tightening. The hook can easily be removed after lowering the vehicle to the floor. The inboard rear brake calipers mount on the final drive unit. Centering of the disc is accomplished by adding or subtracting shims between the disc and the final drive output shaft. Shims are available in 3 thicknesses, 5, 10, and 20 thousandths. Note the semi-round shape of the centering shims. Do not confuse these with the square camber adjustment shims, which are positioned between the disc and the drive shaft U-joint flange. The wishbone inner fulcrum bracket attaches to the final drive unit and is shimmed to align it with the subframe bore. If the subframe is changed, shims are available in 2 sizes, 5 and 7 thousandths, for alignment to ensure an accurate fit of the wishbone inner pivot shaft. Safety wire is used in several places to prevent fasteners from loosening. At the forward radius arm mountings, the wishbone inner fulcrum brackets, the brake caliper mountings on Salisbury final drive equipped cars, and the final drive to subframe mounting hardware. Be sure the safety wire is installed so that the fasteners cannot turn in a counterclockwise direction. The drive shaft universal joints are protected by shrouds. When these are installed, be sure to align the grease fitting with the access hole. Also, reverse the position of the clamp screws on each shaft to keep the assembly in balance. The aluminum alloy hub carriers support the rear wheels and form the outer vertical suspension members. The semi-floating design allows suspension compliance and provides long bearing life. The hub end float is checked by mounting a dial indicator on the hub carrier with the contact pin touching the hub flange. Move the hub carrier in and out to read the end float. The maximum allowable end float is 6 thousandths. The nominal specification is 2 to 4 thousandths. The end float is determined by the thickness of the spacer, located between the hub and the drive shaft outer universal joint. Spacers are available in sizes from 109 to 151 thousandths in 3 thousandths increments. Measure the spacer with a micrometer and select the size spacer necessary to give the nominal specification of 2 to 4 thousandths. The semi-floating design of the hub and carrier may cause confusion when determining the spacer thickness. The rule to remember is decrease spacer thickness to decrease end float. Increase spacer thickness to increase end float. The hub and carrier assembly are withdrawn from the drive shaft to gain access to the spacer. Tool BLT 1072 is used for this purpose. Remove the outer fulcrum shaft grease nipple to allow the hub to swing down when withdrawn. Thoroughly clean the shaft and hub splines and apply Loctite stud lock before reassembly. Torque the drive shaft nut to 100 to 120 pound-feet. The wishbone outer fulcrum shaft pivots on taper roller bearings. During assembly, the nominal bearing preload of 1/1000th is adjusted by shims. Preload shims are available in two thicknesses, 3 and 7 thousandths. These are positioned between the fulcrum shaft spacer tube and the bearing cones. The preload is checked with the hub removed from the vehicle and mounted in a vise. Two methods may be employed. One uses oversized machine washers and a feeler gauge to measure the hub movement. The other uses a dial indicator to measure the hub movement. Subtract the total hub movement plus 1/1000th to determine the correct thickness of the preload shim pack. Additional shimming is required to center the hub in the jaws of the wishbone and prevent the wishbone jaws from being drawn in when the pivot shaft nut is torqued. Centering shims are also available in thicknesses of 3 and 7 thousandths. Be careful not to damage the shims when assembling the components onto the wishbone. Do not confuse the preload and centering shims. Both have the same inner diameter. However, the preload shims have a smaller outside diameter, the centering shims a larger outside diameter. Rear suspension lubrication is required at 12 places. The 4 drive shaft universal joints, the 4 wishbone inner pivots, the 2 wishbone outer pivots, and the 2 hubs. The hubs are not pressure lubricated. The front and rear suspension systems of the XJ6 and S are nearly identical. However, the propeller shafts and final drives differ on the two cars. The final drive unit is an integral component of the rear suspension system and is manufactured by either Salisbury or Dana. Salisbury units are field serviceable and are currently used in XJ6 cars only. No service or repair provisions are made for Dana units. Service problems are rectified by unit exchange. All Dana units are of limited slip design. Salisbury units are supplied with or without limited slip. Salisbury limited slip is identified with a tag reading PL. Brake caliper mounting is different on Salisbury and Dana. Salisbury units have caliper mounting brackets integral with the output shaft flanges. The caliper mounting bolts are safety wired to prevent loosening, and solid brake discs are used. Dana units have the calipers mounted directly to the housing. No safety wire is used, and the brake discs have holes to allow access to the caliper mounting bolts. Due to the wheelbase and powertrain differences in the two cars, XJ6 and XJS employ different propeller shafts. XJ6 cars have a 3 universal joint shaft with a center bearing and support. Sliding splines are located at the front end. XJS cars use a 2 universal joint shaft with no center bearing or support. The sliding splines are located at the back end. Certain service operations to the final drive and propeller shaft can be carried out without unit replacement or overhaul. Salisbury final drive units employ taper roller bearings to support the pinion shaft and the output shafts. The preload on the bearings is set by torquing the shaft nut to compress a collapsible spacer and measuring the rolling resistance with a torque screwdriver. If seal or bearing replacement becomes necessary, the bearing preload setting must be considered during the procedure. The output shaft assemblies are removed from the final drive for service. Fit a new collapsible spacer during reassembly and set the bearing preload. Note that the preload setting is different for new bearings and reused original bearings. Finger tighten the shaft nut to eliminate bearing play and measure the rolling resistance with a torque screwdriver and adapter. Record this initial measurement. Then tighten the nut in very small increments to collapse the spacer until the specified rolling resistance is achieved. New bearings should be set at 10 to 20 pound-inches more than the initial measurement. Reused original bearings should be set at plus 4 to 8 pound-inches. Caution: if the specification is exceeded, do not loosen the nut. Replace the collapsible spacer and repeat the procedure. After installation of the output shaft, secure the hardware with safety wire. The pinion shaft cannot be removed without disassembly of the final drive unit. Therefore, seal replacement must be accomplished while reusing the collapsible spacer. Mark the pinion nut, shaft, and flange before disassembly. After seal replacement, apply Loctite stud lock to the shaft threads and tighten the nut only to align the marks while holding the brakes with a pedal jack. Caution: tightening the nut beyond the marks will increase the preload on the shaft bearings. This may lead to bearing failure. Propeller shaft service is limited to the universal joint spiders and flanges, the gaiters and clamps, and in the XJ6, the center bearing assembly. To ensure smooth operation and full service life, universal joint indexing must be maintained when the propeller shaft is separated. Correct indexing places the universal joint yokes 180 degrees apart in sequence along the length of the propeller shaft to allow free up and down motion. Note that the rear portion of the XJ6 shaft does not move and therefore has the two shaft yokes aligned. Sliding spline joints have arrows to set the indexing. The center bearing yoke joint of the XJ6 shaft must be marked before separation to ensure alignment during reassembly. Apply Loctite stud lock to the splines before assembly. The XJ6 center bearing housing is positioned vertically and horizontally for smooth propeller shaft operation. Vertical adjustment is set by 1/4 and 3/8 inch spacers. These should always be replaced as originally installed during manufacture. Horizontal adjustment must be reset when the assembly has been removed for any reason. Position the bearing full right, then test drive the vehicle and check for propeller shaft vibration. Move the bearing to the left in small increments until the vibration is eliminated. The Jaguar suspension and drivetrain systems play a key role in providing the legendary Jaguar driving experience. Your understanding of these systems and their specialized service procedures will help to ensure that the Jaguar driving experience is maintained throughout the life of the vehicle. Remember, the service information shown here is in the form of service notes. Detailed procedures and techniques are found in the appropriate service manual. This completes Suspension and Drivetrain, Part 2, another Performance Masters Service training program.